I have my internal system here that I'm going to use as a router. The first thing that I need to do, of course, is be sure that I have multiple network cards installed and enabled. One network card in this system is going to be connected to my backbone of my network, and the other network card will be connected to some sort of a department or some other subnet in my environment. I'm going to come into my control panel, right-click on Network Connections and choose Open, and this will bring me in where I can see my two network interfaces. I've labeled them as Backbone for the network interface that's connected to the backbone of my environment, and Marketing for the network interface that is connected to the marketing subnet in my environment. If we take a look, we can see that these have very different IP addresses as well. My backbone is running on a 10. Network. Let me close this and take a look at my marketing. Marketing is running on a 172 network. So the problem here is that packets from the marketing network will not make it to the backbone network unless I configure routing on this system. But what about the trace logs? Well, let's look at that. I'm going to come down to Start, and I'm going to select Run, and I'm going to hop into the regedit program. And inside regedit, I want to navigate down through HKey Local Machine, Software, into Microsoft, and underneath the Microsoft key, you want to find the tracing key. The tracing key has one key underneath it for a lot of different services inside routing and remote access. And unfortunately, a lot of these aren't extremely useful as far as their names are concerned. But there is one that is very good to take a look at, and that is PPP, the point-to-point protocol. If you come into the point-to-point protocol and you enable file tracing here by turning on 1, this will log all of the different PPP information into your Windows directory tracing so that you can see what's happening with the point-to-point protocol. PPP is used for both demand dial, router-to-router VPNs, and people trying to dial in, for instance, a remote access client who's trying to dial in over a modem or some sort of a VPN. All this information will be sent into the tracing directory so you can take a look in much more detail at what's happening on your system. How much detail? Well, if you open up your Windows directory and the tracing directory, you'll see exactly what I mean. By checking that box inside routing and remote access, you've enabled tracing for every service that RRAS is functioning with right now. I'm going to click on Start and Run, and I'm just going to type in C:\Windows\tracing, and that's going to open up my tracing directory. Inside here now, I've got all of my different tracing log files for everything associated with routing and remote access. Some of them have a lot of information, some of them have none, depending on what's happening at this particular point in time. But if you're having problems with NAT, for instance, here's the NAT helper. I could double-click on this particular log file, and if I actually understand what I'm looking at, this is extremely complex information that's mainly meant for Microsoft if they need to help you troubleshoot a really complex issue. You can look through here and see what's going on. But some of the more normal logs, such as PPP, you can take a look at the PPP log, and this will show you the establishment of sessions as people try to dial in, and the breakdown and teardown of sessions as people hang up their VPN or their dial-up connection. But the easiest way by far is setting up what's known as static routes. I'm going to cancel out of this box because static routing does not need the installation of any routing protocol at all. Static routes is simply putting in routes manually, telling your computer how to get from one network interface to the other network interface, how to route packets from one subnet to the other subnet. And of course, you've got to have two routes in there. It's got to know how to go back and forth between the two. So let's take a look at setting up static routes in our small environment. The other nice thing is there's a little bit of magic here when you just have a simple routing machine like the one I've got. Notice I don't have anything listed in my static routes, but if I right-click on static routes and choose Show IP Routing Table, what we'll notice is we will see that there already is a route to the 10.1.1.0 network and a route to the 172.16.10 network. It automatically put these two routes in because those two routes are the ones that it is directly connected to. So if these are the only two subnets in my environment, I'm done, right? I already have these routes here ready to go. Well, let's test it out. I'm going to open up a command prompt. I'm going to come down to Start. I'll click on Run and type CMD for my command prompt. And let's try pinging a host on each side of the router. I'll ping 172.16.10.101, which is a host that's on the marketing subnet. Great, it responds. And let's ping 10.1.1.11, which is the server on the backbone. It responds. Okay, So that works. Now the next test is to go into the subnet and try to ping through the router to see if it works. So let's do that. Here we are on a computer that's running on the marketing subnet. What I want to do is I want to open up a command prompt on here. So I'll come down to my Start menu and open the command prompt. And what I'd like to do is launch a couple of pings. Now, first thing I'm going to do is ping 172.16.10.1, which is the router on this side. It's the marketing side of the router, and of course that's going to work. Now let's go one step further. Let's ping the backbone side of the router, which happens to be 10.1.1.51. Okay, that's working as well. So the router itself is routing the packets just fine. I was able to ping both interfaces of the router. All right, here comes the test. Now let's ping a server on the other side of the router. Okay, I'm excited. Here we go, and request timed out. What's the problem? What's happening here? My packets made it to both interfaces of the router, but when the packet made it to the server on the other side of the router, it never came back. What that tells me is that that machine, that server, the 10.1.1.11 server, does not understand how to get back to the 172.16.10 network. That's the problem with static routes. You can't just set them up in one spot and hope that they're going to work. Every single router, every single computer in your environment needs to know how to get to every single location in your network. So the first thing that we need to do is be sure that RIP, our dynamic protocol, is turned on all routers in our environment. So I'm going to Alt-Tab back to Routing and Remote Access. Let's see, my routing table is open, so I'll just close that down. And here we are back at IP routing. Now I need to add RIP in as a protocol that I can use for routing. So I'm going to right-click on General and choose New Routing Protocol. I'll select RIP version 2 and choose OK. And then I get a RIP container here. Now what I need to do is add in the interfaces that are going to be utilizing RIP. So I'll right-click on RIP, New Interface, and it shows me the interfaces that are already configured inside Routing and Remote Access. In this case, I want to choose the backbone interface because that's the interface that I want to send RIP announcements on. Now I have to configure my RIP properties. I'm going to leave it at periodic update, which means it'll automatically send out its broadcasts. Outgoing protocol will be RIP version 2 broadcast, that's fine. Incoming either RIP 1 or RIP 2. You've got to be sure that all of your routers match, so whenever you set this up, no matter what choices you make, be sure that it's the same on all of them. For instance, if you're going to be using a strictly RIP environment, RIP 2 environment, you may want to go to RIP 2 multicast for better efficiency in the broadcasts and the information being sent out. I'm going to leave this at its default and select OK. And it's now set up and ready to go. So this will begin broadcasting the routes that it knows about over the backbone interface. Now I've got to be sure that there's a computer on the backbone interface that can listen to these RIP announcements. Let's go set up RIP on the other server running on my backbone. Now, running on the other server on my backbone, this is my edge server. This is the server that actually connects me to the internet. The first thing that I want to try to do is I want to try to ping the other server on the backbone to be sure that works. Okay, so connectivity there is fine. So I'm now pinging the router that I just set RIP up on. That works just great. Let's try pinging the computer that's on the marketing subnet. Now because this computer does not know the route, this should not currently work. There we go. It's going to time out. Now what I need to do is set up RIP on this server so it will listen to those announcements being sent by the other router. To do that, I need to come down to my Start menu, click on Start, and then I'll choose Routing and Remote Access. Inside Routing and Remote Access, I need to be sure that I have RIP available. In my IP routing container, I do not see RIP, so the first thing that I need to do is right-click on General, New Routing Protocol. I'll choose RIP, select OK, that'll install RIP, ready for use. Now in RIP, I need to add the interface. This time I'm going to add my internal NIC. I want to add the NIC again that's connected to my backbone. That's this internal NIC, so I'll select that and choose OK. I'm going to leave all of these at the defaults. That way I'll be sure that it matches the other router that I set up and select OK again. Now if we take a look, we can see immediately in the interface here that I've already received one response. So let me right-click on my static routes and show my IP routing table. And we can see that I now have a route to 172.16.10 and that it was learned by RIP. I love this. This shows you exactly where each route came from. So that was amazing. That was as easy as it was. As soon as I turned it on and dumped it in here, it received a response. Those are received every 30 seconds and sent every 30 seconds. and it received it via RIP. So now if I Alt-Tab back to my command prompt, and this time I try to ping 172.16.10.101, it gets there and back just fine because now it knows that any packet going to 172.16.10 should be sent to the internal router instead of to the normal default gateway that it uses. Let's configure routing and remote access on our corporate router. This is the router that's hooked up to the public phone network. I already have a modem installed in this system, and this is going to be the one that the branch office dials into. This is my 10.1.1.0 network. The first thing that I need to do is I need to ensure that I have a network interface that the demand dial routing is going to go across. So let me right-click on Network Interfaces and select New Demand Dial Interface. In this case, it'll pop me into a wizard, so I'll choose Next. It asks me to give the interface a name. Now, I'll give you a definite hint here that you need to pay attention to. Name these according to who's dialing into them. It'll make your life much simpler. So I'll name this one Branch. That way I will know who's dialing into this interface. Let me choose Next. How is this connection going to be established? Is this going to be using a modem? Is it a VPN? Is it PPP over Ethernet? In this particular case, it's over a modem, so I'll leave modem chosen. Next. It'll ask me which modem or other adapter do I want to use. I'll select the modem that's already installed in my machine and select Next again. What phone number is going to be dialed in order to initiate this connection? Now this is where you need to make a determination. Is this a one-way or a two-way initiated connection? I'm at my corporate headquarters. I'm going to be dialed into. I'm never going to be doing the dialing, so I don't necessarily have to put anything here because this side is never going to initiate the connection. Do I want to route IP packets on this interface? Definitely, because this is what's going to make it possible for my branch office to send information through this router to reach out to the rest of the computers on my network. I do need to add a user account so that remote router can dial in, and this user account must be named the same as the demand dial interface. That's how routing and remote access will know that this user is associated with this demand dial interface. Do I want to set a plain text password if that's the only way to connect? So you've got these other options for scripting that typically deal with the fact that you might be dialing up to an ISP. I'm not in this case. I'm dialing 2003 to 2003. Now, to activate this demand dial connection, I must add a static route. Well, I don't want to activate this connection. This connection is only going to answer. Can I just continue on? Yes, I can in this case. Again, remember, on the other side, I will have to set up a route that will initiate the connection. Notice here, setting up the dial-in credentials, it already populates the username as branch. It asks me to put in a password, so I'll go ahead and do that. You want this to be a fairly complicated password, of course, because this user could be used to try to break into your network. Let me choose Next. Dial out credentials. Now, the one thing that I don't like about this, I was able to leave the phone number blank. I was able to leave the static routes blank. I cannot leave this blank. Even if I'm never going to initiate the dial-up from this side, I still have to put something in here. So I'll just fill this out and select Next. And that's it. It's ready to go. If I choose Finish, my demand dial interface is installed, configured, and ready to run. But I have to configure it on the other side, and you need to definitely understand static routes. I did not add a static route. So when the branch dials into me and connects to this demand dial interface, how is my corporate office going to know to send information back to the other side? How are they going to know to route the information back to the 10.11.12 network? That route needs to be there somehow. On the router in my branch office, the first thing that I need to do is confirm that my 56K modem shows up inside routing and remote access as a port that can be routed across. You always need to confirm that these ports are configured correctly, so I'll right-click on Ports and come into Properties. And then I'm going to double-click on my 56K modem to configure it, and I want to be sure that it's usable for inbound and outbound routing. I want to be sure that this can be used for demand dial routing. Confirm this. If you ever find that your demand dial connections are not working correctly, this is a great place to look. Once you've done that, you can select OK, and I'll OK one more time out of this. Then I want to come up, and I need to confirm that demand dial routing is turned on itself. So I'm going to right-click on the server, select Properties. This is inside Routing and Remote Access, and you need to confirm that your machine is enabled as a router. If this is the first time that you've done this on a machine, if this is the first demand dial interface that you've set up, you should always confirm that it is configured and ready to go as a router. and that in this case LAN and demand dial routing are available. Then come over to the IP tab and confirm that enable IP routing is on. If this is not on, then the packets from the remote network will only be able to make it to this server, not past this server, not out to the network that's connected to this server. So once you've confirmed those items, again select OK. It tells me that I've got to restart the router service, so I'll say yes, go ahead and do that. It's going to restart the router service to enable the LAN and demand dial routing functionality. Once that's configured, I now have my network interfaces container. Inside here, I now need to add my demand dial interface. This is the corollary. I'm just going to basically run through the exact same thing that I did in the corporate office, except this time I'm going to specify parameters that make sense for the branch office. So the interface name in this particular router is going to be named corporate because that's what I'm dialing up to. I'm either going to dial to the corporate or corporate's going to dial into me, but this identifies who's connecting to this particular interface. I'm going to be connecting using a modem. I'm going to select my modem, be sure that's the one I'm using. Now in this case, on the corporate side, I did not put in a phone number because the corporate side was never initiating the connection. But in this case, my branch is initiating the connection, so I need to put in the phone number that I'm going to dial up to. Do I want to route packets? Yes, I do. Do I want to add a user account so a remote router can dial in? No, I don't in this case because I don't care about that. The corporate is never going to dial in to me. So I'm going to choose Next. I do need to add a static route. What is going to initiate this connection to the corporate network? What I'll do is in the destination, I'll put in the IP network that specifies the corporate side, 10.1.1.0. If you do have a routed network over on the other side, you should try to use some type of a supernet that wraps up the entire corporate network all in one. For instance, if your corporate network were really large, maybe all of the addresses are 10.1.0.0, and then over there you subnet it as necessary. In that case, you could just do a network mask of 255.255. Then anything destined for 10.1 would go across this demand dial connection. I only have a small corporate network though, 10.1.1. So I'm going to put in that one subnet. I'm going to put in the mask of 255.255.255.0, and I'm going to leave the metric as 1 because this is going to be the interface that must be used anytime a packet needs to go to the corporate network. Once that's in, I can choose Next. Who am I going to be dialing out as? What username and password do I need to dial into the corporate side? Well, on the corporate side, the name of the router and the name of the user was branch, so I'll put that in. Put in the name of your domain, and of course the password that you put on the user account that you're going to be dialing in as. I'll choose Next and Finish. Now there's one important thing that I want you to see about that static route that was implemented. I'm going to come into my IP routing container, down to my static routes where this route was created, and I want to double click this one and check this box. Use this route to initiate demand dial connections. If this is turned off, for instance, if I were configuring this on the corporate side, I could create a static route on the corporate side and just be sure this checkbox is off. That way the corporate side will never initiate a connection. Here on the branch side though, I definitely want this route to initiate a connection, so I need to be sure that checkbox is on. I'll select OK, and that's it. Once your hardware is configured, once everything's in place, your usernames, your passwords, as soon as this router receives a packet destined for 10.1.1.0, any computer on that network, it will initiate the dial-up and the connection will be created. Currently, we're on the corporate router machine, and what we want to be able to do is set up the VPN across the internet so that I could issue a command to ping a computer out in the branch office. 10.11.12.101, for instance, which is one of the client computers in the branch office. Currently, of course, that's going to time out. But what I need to do is get the demand dial interface with the static route set up so that this particular call would initiate the demand dial itself. So let's Alt-Tab over to Routing and Remote Access and see about configuring this and setting it up. The first thing that we need to do is we need to configure the demand dial interface to use VPN. So I'm going to right-click on Network Interfaces and select New Demand Dial Interface. I'll go ahead and choose Next in the wizard. The interface name in this case is going to be the interface that I'm dialing to. So this one represents the branch VPN, so I'll go ahead and fill that in. I'm going to put in branch with the VPN on the back so that I designate exactly how this is set up. So once I've got that in, I can choose Next. I want to connect using VPN, Virtual Private Networking. Next. I'm going to use PPTP in this particular case for ease of setup. For security reasons, if you've deployed certificate services, of course, you'd want to use L2TP. PPTP is simply based on username and password, and that's what I'm going to use in this particular scenario. Once PPTP is chosen, choose Next, and put in the IP address that you're going to be connecting to. This will be the public IP address on the router for your branch office. So I'm going to fill that in for my little environment here. Once I've filled in the information, I'll choose Next. I want to route IP packets, and I want to add a user account so a remote router can dial in. This is going to be a two-way initiated connection. Either side can initiate it, so I want to be sure it's set up both ways. I'll choose Next. Now I need to set up my static routes. What is the network in the branch office? What static route do I need so that traffic destined for the branch office will initiate this connection? I'm going to fill in 10.11.12.0, which is the network in the branch office. Put in the mask to help represent that and say OK. Once you've got that filled in, choose Next. If you had a routed environment over in the branch office, you could fill in multiple static routes, and then any of those routes, of course, would initiate this connection. I'll choose Next now. This is the name and password that the branch office is going to use to dial in to this particular server, to this particular router. Notice it's pre-filled in a username that matches the demand dial interface. That's a requirement for our RES to function properly. All I need to do is put in the password. This username and password is going to be filled in on the branch VPN when I set it up so that it can dial into corporate. I'll choose Next. And now it's asking me for dial out credentials. When corporate dials out to branch, what information needs to be set? Well, the username is going to be corporate VPN. The domain, if I had a domain environment in the branch, I would fill this out. My branch at this point in time is simply a work group. So if I wanted to, I would put in the server name of the computer that's going to be accepting the VPN connection, or I'm just going to leave it blank and that'll work out as well. As long as the username and password are correct, it will accept that connection in. That is not the case with a domain environment. If I'm dialing into a domain, I need to fill this in. In my case, though, the branch office is not a domain, so I don't need to fill that in. I'll put in the information. This information will have to be repeated again on the branch side, and that's it. I can select Finish now, and my demand dial interface has been created. My static route has been created. So now whenever any traffic destined for 10.11.12 hits this router will initiate the demand dial connection. There are a couple of other items that you need to confirm. Under Network Interfaces, I'm going to come into the properties of my branch VPN demand dial interface. On my Options tab, what type of a connection is it? Is it demand dial and when should I hang up? Or I'm going to choose persistent because this is over the internet, so this connection should never be disconnected by the routers. If there's a hiccup in the network, in the internet, that's fine. It will be reinitiated when traffic again tries to flow. So I'm going to leave this as persistent. Your Security tab allows you to choose how you're going to connect out to the remote VPN. So if you were connecting out using some type of other security settings, you could set that up in here if necessary. Or if you were using L2TP with what's known as a pre-shared key, you could set that up under IPsec settings. And finally, under networking, you can choose what protocols are going to be used to initiate this connection. Think of this connection as a WAN connection. That's in essence what it is. So you could come in and you could fill out an IP address, for instance, that you're going to set up on this particular connection. I'm going to leave all of this at the defaults, except, of course, for the persistent connection. I'm going to leave that and select OK. And speaking of IP addresses, there's one more thing that you definitely need to confirm. I'm going to right-click on my server and choose Properties, and come up to the IP tab. The IP tab controls how IP addresses are assigned to clients who dial in, including demand dial routers. What IP address is going to be assigned to that particular client when it dials in? If you have a DHCP server set up, you of course can choose to use DHCP, or if you choose, you can set up to use a static address pool. I'm going to leave this at the default so we can see what happens here. I'll select OK. And that's it. We've got it configured. I've confirmed my IP addressing. I've set up my names and passwords, and I've set it up as a persistent connection. So my corporate side is ready to go. I now need to do the same thing on the branch side. Out in routing and remote access on my branch server, I need to set up the exact same type of demand dial interface. Basically just mirror it, however, of course, to represent the corporate VPN. So I'll right-click and choose a new demand dial interface. Brings me into the demand dial wizard. I'll select Next. What's the interface name? In this case, the corporate is going to be the one dialing in, so that's what I'll put in here to represent my corporate VPN. I'll choose Next, and I run into a problem. VPN is not available. This is one thing that you definitely need to check on your routing and remote access service before you get started. Come up to your ports and be sure that you have a port enabled for routing. My PPTP and L2TP ports are not enabled for routing at all. So that means I need to enable inbound connections. I do that by right-clicking on ports, selecting properties. PPTP is what I'm working with in this case, so I'll double-click it and select demand dial routing connections, inbound and outbound. That will turn on the ability for the inbound connection and also for the outbound connection to be initiated. I'll choose OK. OK one more time. And now let's come up to my network interfaces and try to create my demand dial. Right-click, new demand dial interface. Next, corporate VPN. Hey, much better. We now have the choice for VPN. So remember, if this isn't a choice, be sure that you have a port that is configured for outbound connections, for inbound and outbound demand dial connections. If you do, then you might need to take a look at the properties of your server to be sure that demand dial is enabled there. There's multiple places that you need to check. I'll select Next. I'm using PPTP. Next. What IP address am I going to dial out to? This is going to be the public IP address assigned to my corporate VPN server. So I'll put that in. Select Next. Route IP packets, and again, yes, I want to add a user account because either side can initiate this. So I've got to have the user set up on both sides. I'll add my static route in. My corporate network is 10.1.1.0. Put in my Class C subnet mask and select OK. Again, add any extra static routes that you need to fully represent the corporate network. If you had a routed environment, you'd need to add all of them in here so that all of them can be routed across. I'll select Next. Now, the password for the corporate VPN user to dial in. This is the same information that I already put in on the corporate side, so you need to be sure that it matches what you already put in over there. I'll select Next. These are my dial out credentials. What did I put in on the corporate side for dial out? I'll put in the username. In this case, I am connecting to a domain, so it's critical that I put in a domain name. And of course, the password that was assigned to the user. Next, and finish. All right, let's take a look at the other items that we need here. I'll come into the properties of the demand dial interface. Options, set it as persistent so it doesn't hang itself up. I'll select OK. And let's take a look at my IP addressing. I'll right-click on my server. Properties, IP tab, and it's using DHCP, so that's fine. I'll go ahead and just X out of this one. And now I want to test this. In order to test it, you can actually right-click on the network interface itself and choose Connect. Notice right now the status is disconnected. So when I choose Connect, it'll actually give me a little box showing me what's going on and give me a little bit of a clue if it does not connect successfully. In this case, though, it simply goes away and the connection state now lists connected. Great. Let's disconnect this, and let's try it as if one of the clients on our network were actually causing the connection. So I'm going to Alt-Tab to a command prompt, and I'm going to ping a computer on my corporate network. And I get the reply. This is because I've set up the persistent connection, so even though I disconnected it, it went ahead and reconnected the interface. If for some reason the interface were disconnected, what I would see is I might see a period of time where I get a destination host unreachable or a timeout while the connection is established. Let's go back over to the corporate side and see if it's working both ways. On the corporate side, I see my branch VPN demand dial interface, and it also represents connected, so it sees the information traveling back and forth. If I want to confirm it, I can always right-click on static routes, show my routing table, and make sure that my route for 10.11.12 for my branch network is in here. Notice that it reports its gateway as 169.254. This is an APIPA address, an automatic private IP address that was assigned because I told my RRAS, my routing and remote access server, to assign IP addresses using DHCP. Well, DHCP wasn't available, so when this connection was established, it picked an APIPA address. That's fine because both sides are utilizing APIPA, so my routing is working just fine over this interface. Let me go ahead and close this down. and I'm going to Alt-Tab over to a command prompt window and try to ping a computer in the branch office, and it works out just great. So you can see now I have traffic flowing back and forth both ways, and if I'm utilizing some type of a dynamic routing protocol, that route, this static route from my branch office, will be advertised throughout my corporate environment, so all computers in my corporate environment can now talk to my branch office. One last thing I'd like you to see on the network interfaces for demand dial. Every once in a while you want to be able to restrict them. Maybe this is not a persistent connection. Maybe it's a connection going over some type of media that you need to pay for. So you don't want every little blip that comes across the network to launch that connection. Well, if I right-click on my interface, I can choose to set IP demand dial filters or dial out hours. These allow me to control when this connection will be established. If I come in to set IP demand dial filters, for instance, I could tell it that all traffic except web traffic, or only web traffic, for instance, will be what initiates the connection. This is not a filter as in dropping traffic across the connection. This filter only controls what initiates the connection. So between demand dial filters and dial out hours, you have a great way to tweak when this demand dial interface can launch itself and dial out to the remote side. On my computer that connects my network to the internet, what I need to do is go to my internet connection, to the network card that's attached to the internet or the dial-up connection that attaches to the internet. That is extremely critical. You do not want to enable internet connection sharing on your internal network card. That'd be a bad thing. So in my case, I have one here that's my external NIC. This could be connected to a cable modem, to other type of broadband connection. It doesn't matter. What I'm going to do is right-click on it and choose Properties. And in the Properties dialog, I'm going to come over to the Advanced tab. On the Advanced tab, I have two choices for Internet Connection Firewall. This is a great one to turn on if you are a single user at home, for instance, and you're connected directly to a broadband cable modem or DSL, and you have a public IP address. Definitely turn this on. But in my case, I've got other computers on my network that need to use that same connection, so I'm going to turn on internet connection sharing. Actually, I'm going to turn on both of them for the best possible protection of my internet connection. Once I've done this, I'll go ahead and select OK. And it comes up and tells me, all right, what I'm going to do is I'm going to set your LAN adapter to 192.168.0.1. You may lose connectivity. This is basically telling me everything it's going to do automatically and telling me that if I have other computers, I need to set them to obtain IP addresses automatically. Do I want to do this? Yes, I do. Let's see. It cannot be enabled because routing and remote access has been enabled. The two are mutually exclusive. You cannot turn on internet connection sharing and the internet connection firewall if you're using routing and remote access. You can see Microsoft has aimed them at two very, very different audiences. ICS is aimed at SOHO, small office, home office, while routing and remote access is aimed more at a corporate network. Let me click on Start. I'm going to come into routing and remote access and simply disable it briefly so we can see internet connection sharing at work. I'll right-click on my server, disable routing and remote access. Yes, I want to continue. And that's all there is to it. This is disabled routing and remote access. And once the service stops, I can Alt-Tab back to my network connections and again come into the properties of my internet connection, Advanced, turn on both the firewall and sharing, select OK, and then select Yes, I do understand what's going to happen. And it will go through the configuration, turning on the firewall, turning on sharing, and when it's done, I will have NAT enabled on my external interface. You'll know that this has been done because you get two extra icons on your network connection icon. You have the little sharing hand that normally is associated with sharing a folder. This is now also on my network connection. And the lock icon tells me that the firewall has been enabled here. One word of warning, do not enable the firewall on your internal connection. That will make it so that nobody can connect to your computer to get to resources. Let's take a look again one more time. I'm going to right-click, come into Properties, and on the Advanced tab, there was one other button that I could have played with that gives me ultimate control over what can and cannot get into and out of my network. Down at the bottom is the Settings button. The Settings button changes depending on whether or not I have the firewall turned on. If I do not have the firewall turned on, I won't see Security and ICMP. These two tabs are here because I do have the firewall turned on. The services, however, allow me to map inbound services from the internet onto my network. So I've got a small network here that I'm migrating from internet connection sharing into routing and remote access NAT. So let's go ahead and launch routing and remote access, come into its console, and what I need to do is get in and configure it. If it has not been configured before, what you're going to see is the red down arrow, and when you right-click it, you have the choice to configure and enable routing and remote access. This is the problem that you're likely to run into if you are a small environment and you're trying to migrate up to NAT in routing and remote access. It tells me that the Internet Connection Firewall is currently enabled. ICF, the Internet Connection Firewall, and ICS, Internet Connection Sharing, are mutually exclusive with routing and remote access. They utilize a lot of the same drivers, and only one of the utilities can run them at the same time. So what I need to do first is go in and turn those two utilities off. So I'm going to click on Start. I'll come up to my Control Panel, Network Connections, and I want to come out to my external NIC because this is the one that has Internet Connection Sharing and the Internet Connection Firewall on it. What I'm going to do is right-click on it and choose Properties. Right off the Start menu you can do that. Right-click and choose Properties. And then inside here I'm going to come up to the Advanced tab and simply turn off ICF and ICS. I'll select OK. Turning it off could expose you to dangers. Are you sure you want to do this? Yes. All right, now I want to come in and configure routing and remote access, so I'm going to right-click on my router and select Configure and Enable. And it'll bring me into the wizard that allows me to set all of this up. I'll choose Next. And my goal at this point is to simply set up NAT. So I'll choose Network Address Translation and select Next. And it's going to ask me which is going to be the public and which is going to be my private interface. I'm going to select my public interface that will connect to the Internet, and then I'm going to go ahead and make sure that security is enabled by using the basic firewall. These two pieces here are the RRAS versions of Internet Connection Sharing and the Internet Connection Firewall. Here's the sharing piece, of course, with NAT, and down here is the Internet Connection Firewall equivalent known as Basic Firewall inside Routing and Remote Access Server. So choose your public interface, choose Next, and that's really it. I'll go ahead and select Finish. It's going to configure the services and start routing and remote access for me. Once it's done, I can go in and take a little bit more in-depth look at what it did for me. Let me expand it. I'm going to right-click on my router and select Properties. And I can see that what it's done is it's simply turned on the routing piece and LAN routing only. NAT does not require demand dial. NAT, of course, does not require the remote access server. So it does not turn those pieces on. If you need to use other features of RRAS, you can come in and configure those yourself. But at this point in time, all I'm concerned with is NAT, so I'm going to leave those the way they are. I'll select OK. And then what I want to do is I want to come in and take a look at my NAT Basic Firewall section. This is the actual routing protocol for NAT. And when I choose it, what I will see is my internal and my external NIC have been added in here. Now, why do I need them both in here if the only one I really care about translating on is the external? Well, if I right-click on my external and choose Properties, what I will see is that the wizard went ahead and designated this as a public interface. It enabled NAT, and it enabled the basic firewall. Let me X out of this so you can see what the difference is between my external and what it did to the internal. I'll right-click Internal, choose Properties, and this one is simply designated as the private interface. You must have a public and a private interface in order for NAT to work properly. So you've got to be sure they're designated as such. I'm going to X out of this one again. If you do need to set this up manually and you don't go through the wizard, be sure that you do that. You add in a public and a private interface. Let me right-click back on the external and come into Properties so you can see what we set up if we need to do this manually or if we need to add some extra options to this. The address pool are your public addresses that you want to assign to NAT. So if you have multiple public addresses that you want to map through or you want to utilize for outbound NAT, you can add those in here. So I could add in a bunch of different addresses and put in my mask. I'll say OK. And it adds in that range. If you actually do have a particular subnet, you can just put in your starting address and your mask, be it 240, 224, whatever your mask is, and it will fill in the to IP address, the end IP address for you. You can then reserve addresses for use by specific network computers on the private side if you want. For instance, if I wanted 1115 to map through to one particular machine on the private network, I could do that inside my reservations. So this is a great way to allow you to set up one public address to go to one private address. On your Services and Ports tab, this is where you can choose what's going to be passed through into your network. Are you running an email server on your network? Well, you can configure that by simply checking the box It's going to ask you what public address do you want this mapped to. This, of course, is going to be what you set up in DNS for the rest of the world to find you. And then what private address do you want it to go into? So you'd put in the IP address for your email server here. And at that point, any inbound connections that connect to this interface, if you only have one IP address on the interface, it'll be to that one IP address. If you do have an address pool or multiple publics, you should probably pick the specific IP address that they're going to be connecting to. But in any case, any inbound email traffic will be forwarded to this machine inside the network. This machine inside the network, of course, will respond, and those packets will be forwarded back out through NAT, out to the machine on the public internet that initiated them. So it's pretty easy to get your inbound services set up exactly the way that you need. If one that you need is not here, then you can go through and set it up. Maybe you need some sort of gaming protocol set up, of course. You can always add that in, typing in a description, the IP address, TCP or UDP, put in your ports, your public and private addresses, you're ready to go. I'm not going to add one in right now, though, so I'll just X out of this. The ICMP tab allows you to choose what pings or what Internet Control Message Protocol messages, such as ping, you're going to respond to. If somebody tries to ping your NAT box, do you want to respond to that? Do you want to just drop it? A lot of times people just want to drop it so that their public addresses don't respond at all. It can help a little bit if there are people out there trying to do port scans. So you can select all of these different options, get them configured exactly the way you need for your environment. Once you've done that, select OK. And the last thing that you should take a look at is the properties of NAT itself. What I had just done was go into the properties of the network card. This time I'm going to go into the properties of the NAT protocol. So I'm going to right-click on it and select Properties. And then I'm going to come up to my Address Assignment tab. The Address Assignment tab chooses where my IP addresses are going to come from for the computers on my network. Do I want NAT to give out the IP addresses? If so, I need to turn this on. This is what's known as the DHCP allocator, and this will give out addresses that I choose. If I have a full-fledged DHCP server on my network and I want it to give out the addresses, I'm going to leave this turned off and DHCP will take care of it for me. Name resolution is for DNS. Do I want NAT to do my DNS for me, or do I have a DNS server? Maybe I'm using my ISP's DNS server, and I want that to do all of the name resolution for me. I make those choices here as well. So you can see you've got a lot of power and flexibility in choosing what you want. Let me go ahead and select OK here. And then if you want to watch and see what's happening with NAT, you can simply take a look at your mappings, see how many ports or how many packets are being sent in and out right here inside NAT itself. So now that it's all configured, we can go over to my other machine and take a look on my private network at using NAT to get out to the internet. So let's go ahead and open up Internet Explorer so we can see if we can get out and browse. Of course, I'm running on Windows Server 2003, so I have the enhanced security configuration, which may make some web pages not work well, but should keep your computer safe from a lot of web-based attacks. I'm going to put in Microsoft.com, and let's see what happens. And we wait, and we wait. The bar's going, so it looks like it should know where to go, but nothing's coming up. Let's go back to the server and see if the NAT is working correctly and see where the problem might lie. Back on my router on my server under Network Address Translation, let's go ahead and move off of it and back on so I can see if I've got some mappings going. So I do, so it's trying to do its thing here, but what's happening? Why can't I get out? Well, you can take a look at what's actually inside the mappings by right-clicking on your network interface for the internet and choose Show Mappings. It will show you what private IP address you're using, it's outbound, and what public IP address it's mapping to. Oh, look at that, a bogus address. This is what I was putting in when I was playing with the public address range just to see what it could do. This highlights one of the critical things that you need to be aware of with network address translation. You need to be very sure that you have the correct public address range in, because whatever you put in there is what it's going to try to connect out to the internet as. So I need to go in and fix this public address range, so I'll close my mappings window, and I'm going to right-click on my external NIC and choose Properties. I'll come up to my address pool, and I'm simply going to yank this range out of here. I'm going to remove that, and what that means, if there's nothing in here, it means it's simply going to go out with the IP address that's already assigned to the external NIC, and that's fine. I have one IP address. NAT works perfectly with one IP address. Now that I've fixed that, let's select OK. And let's go back to my other computer and try it again. I'm going to actually restart my router service here. so that all those mappings go away. I'll right-click on the server itself, all tasks, restart, and this will just clear out all the mappings by starting NAT over again from scratch. All right, so if we navigate off of NAT and back to it, hey, look, we already have some new mappings. Let's see what those are. Much better, much better. Now our private addresses are going out through our true public address that we have assigned to our external NIC. So let's go back and be sure that we're browsing appropriately now. All right, my Internet Explorer has started to go somewhere, but I actually want to start it over. So I'm going to try to close these windows down. And then I'm just going to go ahead and open up Internet Explorer again because it doesn't look quite like it was going to the right Microsoft.com site. Over time, of course, if it can't find the site that you're looking for, Internet Explorer by default tries .nets and .orgs, so who knows where it would have ended up. I'm just going to start from scratch by putting in Microsoft.com again. Now that NAT is set up correctly, it should get to that website without any problems. Let's take a look. All right, so my enhanced security screens come up for Internet Explorer on 2003. I'll just close these. And Microsoft's website comes up. So we can see that network address translation's working fine in our environment. Take a look inside the properties of routing and remote access. On the server itself, if you go into the properties of the server, you can of course come over to the logging tab and choose what level of logging you want to have. You can turn on additional information by checking this box, and that's going to turn on the trace logs for a lot of the routing and remote access services. Remember, this logs very, very detailed information, but if you're having problems, you probably want to pump everything up to maximum logging for this point in time until you solve the problem. The other place that you can log, especially if you're having problems with demand dial, remember, is in your authentication or your accounting provider inside the security tab in routing and remote access. The accounting provider will log all of the authentication attempts as people try to dial in. In this case, Windows Accounting logs by using the remote access policies that you have established inside routing and remote access itself. Once you get the basic logging set the way you want, go ahead and select OK. Here's the remote access logging. This is where any people who attempt to dial in, this is where their attempts are going to be logged. By default, it goes to a local file that's inside Windows System 32 in the log files directory. And this is in what's known as IAS format. If I double-click this, the log file is in IAS format, which is Internet Authentication Service. And there is a tool in the Windows Support Tools that can go through and decrypt this information because it is extremely cryptic. But if you run it through this little parser, you can then open it up in Excel or something like that and take a look at this information to see why somebody's not connecting. Was there a problem with the protocol? Are they using the wrong authentication or the wrong security mechanisms? This file will show you a lot of that information. I'm going to go ahead and select OK here. Also, under each of the different IP routing options, there is more logging information that you can turn on. For instance, with NAT, if you're having problems with network address translation, come into the properties of NAT, and right on the General tab, you can turn on to log more information. So each of these items, each of these different routing protocols, allows you to pump logging up to the maximum amount of information so you can figure out what's going on. Once you've done all of this, of course, you select OK. Then you can go take a look at your event logs and see what's happening.